Scientific notation is a great shortcut way to write really big numbers. For example, if an estimate of the average amount of cells in the human body is 15 trillion, we could write that in a shortcut way instead of having to write this long number out every time. So we can take the standard form of a number, which is the way we're used to seeing it, and we can write it with scientific notation, which we're going to get more into in a bit. So take a moment to write down a couple of examples for these. Scientific notation has a lot to do with the powers of 10. 10 is what our number system is based on. So let's look at what happens with powers of 10. For example, 10 to the second means 10 times 10, which is 100. 10 to the third would be 10 times 10 times 10. It's a factor 3 times to get 1,000. 10 to the fourth, we'd have 4 tens being a factor multiplied to get 10,000. So do you see a connection here? The exponent with the base of 10 is the number of zeros behind the 1. And for every additional 10 being multiplied, you're adding an additional 0, which is a place value. Another place value is being involved. Let's first look at changing scientific notation into standard form. So we have our number 2, and we're multiplying it times a power of 10, 10 to the third. Well, that's the same thing as taking it times 10 times 10 times 10, which is 1,000. So we end up with 2,000. Now another connection we can make is that we're just simply moving the decimal that's behind the number 2 over 3 place values because of the 3 zeros or the 3 tens that are being multiplied in 10 to the third. So I go behind the 2, 1, 2, 3, and there we go, 2,000. Put in your comma. Okay, pause the video and write this scientific notation of 3 times 10 to the fourth power in standard form. So you're going to take 3 times 10 to the fourth, which 10 to the fourth is 10 times 10 times 10 times 10, or 10,000. And so we're taking the 3 with the decimal point behind it, and we're moving the decimal to the right 4 times. 4 is what our exponent tells us. So we move it 4 place values to the right so it gets really large. And so our number is 30,000. So we have to make sure this makes sense. Taking a small number like 3 times a power of 10, 10 to the fourth is a big number, our number better get bigger. And it did. 3 went from 3 to 30,000. Let's try it one more time. Here we have the factor of 6 and 8 tenths. And we're multiplying that times a power of 10 to the fifth. So that's 1 with 5 zeros. 100,000. So we're going to end up moving that decimal point 5 places to the right so it gets really large. 1, 2, 3, 4, 5. Fill in the gaps with zeros. And we end up with 680,000. And make sure it makes sense. We're taking a small number 6.8 times a large number 10 to the fifth, 100,000, so our number better get bigger, and it did. And again, remember that the exponent of 5 tells you how many place values you're moving the decimal to the right. Pause the video and check your progress on this scientific into standard form. So 4 7/75 times 10 to the second is 10 to the second is a 1 with 2 zeros, or 10 times 10, 100. So we're going to take the decimal and move it 2 place values to the right so it gets larger. We end up with 475. In our next set of problems, we're going to take a regular number, which is standard form, and we're going to write it in our shortcut way of scientific notation. Some things to keep in mind. When you have scientific notation, there can only be one number in the lead. For example, 4.2 times 10 to the 7th. there's only one number to the left of that decimal point. It's one number as the leader. And to come up with the power of 10 that we're using, you count how many times the decimal moved to get behind the 4. So I will show you how that works on this number, 4 million. So I want there to be only one number in the lead, so I'm going to take the decimal that's at the back and move it all the way over so it's behind the 4. So I'm going to have 4.0 times 10 to the something. In order to figure out the exponent, how many times or place values did it move over to get there? 1, 2, 3, 4, 5, 6. So it's 4.0 times 10 to the 6th, or just 4 times 10 to the 6th power. Okay, you're going to try this one. Take the standard form and write it in scientific notation. Remember to pause the video. Okay, so we're going to take that decimal that's at the back end and we're going to move it all the way so it's behind the 1 leader in the front. So it's 6.4 times 10 to the something. 6 4/10 times 10 to the power of, and we'll count to find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the power of 10. So in this number, we're still doing the same thing. We're going to take our decimal and move it so it's behind only 1 leader. So we're going to end up with 9.4361 times 10 to something. Alright, it moved over 1 place value, 2 place values. 10 to the second, 10 to the second power. Pause the video and write this number, 583 and 4/10, in scientific notation. Okay, you would take your decimal and move it so it's behind only 1 leader in the front. So it's going to end up here as 5 and 83 hundredths. 5.834, 5 and 834 thousandths times 10 to the something. And it moved over 1, 2, so 10 to the second. So check to make sure this makes sense. If you were to reverse this and go from scientific to standard, you're going to take our 5 something times 10 to the second, or 100. And it's going to go from 5 something to 500 something. And so it does make sense. It goes from a smaller number to a bigger number when multiplying by a power of 10.